Just to make sure you understand this, in Boolean algebra, that's heading towards engineering. When we do A and B, A or C, A or B, it would be best if you visualized these actual components that these guys are representative of. A and B are being fed as inputs into an AND gate. So if you have a 1 on A and you have a 1 on B, then you're going to get a 1 output. If you have a 1 on A and you have a 0 on B, you're going to get a 0 because you have to have a 1 and a 1 to get a 1. That's the law with this component. If you have a 0 and a 1, you're going to get a 0 because the law is you have to have a 1 and a 1 to get a 1. If you have a 0 and a 0, you're going to get a 0. Why? Because the law is you have to have a 1 and a 1 to get a 1. It's that simple. If there's a 0 on any of these inputs, you're a dead man. You're getting a 0. That's it. Period. End of story. 1 and 1. All right. Scooch this over. Talk about A and B. A or B. Pardon me. A or B. Two lines are coming into this guy here. And this guy, which is pretty skewed, is an OR gate. An OR gate, if you have a 0 or a 0, you're going to get a 0. Huh. If you have a 0, I better put it this way to make my life easier. That wasn't too easy. All right. If you have a 0 or a 0, you're getting a 0. If you have a 0 or a 1, you're going to get a 1. Oh, how is that? Because if any of these two inputs has a 1 on it, if this one has an input, that's a 1. Or this one has an input that's a 1, then you're going to get a 1. Either one, this or this, you're going to get a 1. It's that simple. If this one has a 1 and this one has a 0, you're going to get a 1. If this one has a 1 and this one has a 1, you're going to get a 1. If this one has a 0 and this one has a 0, you're going to get a 0. It's that simple. So either one of these getting a 1, you get a 1 output. That's your Boolean algebra for ORs and ANDs. Although sometimes they call them, because of the symbols, they'll call this Boolean addition. They'll call this Boolean addition. And if it's ANDs, they call it Boolean multiplication. But you know, that gets sort of unrealistic when you're dealing with these components. These components are not exactly like math. They act different because they're components and they have specific purposes and definitions. And you have to follow those rules. Okay, I hope that helped. This is George Boole. Wishing you well. Good luck. Bye-bye.